Our next lesson is on prime factorization. Before we talk about prime factorization, let's talk about a few vocabulary words that we'll use throughout this lesson. The first vocabulary word is the word factors. And when we talk about factors, what we mean is numbers that multiply together to make another number. So for example, I could say that some factors of 6 are 2 and 3 because 2 times 3 is 6. So 2 and 3 are called factors of 6. We talked about in our last lesson prime numbers, and so let's just review the definition. Prime numbers are numbers with only 2 factors, and those 2 factors are always 1 and the number itself. So for example, 7 is prime. It has only 2 factors, the number 7 and 1. And then we want to talk about in this lesson something called prime factorization. Prime factorization is when a number is written as a product of all of its prime parts. And we're going to unpack that definition as we go through this video. But prime factorization means when I write a number as the product of all of its prime parts. Okay, when we talk about when we talk about prime factorization, we are going to try to break a number apart into all prime numbers. So when we want to get the prime factorization of 48, we want to break 48 apart into all prime numbers. Okay, and there's 2 different methods that you could do that with. I'm going to show you both. You don't need to know how to do both methods. You need to decide which one of these is easiest for you and just learn that method. Okay, so one of those methods is called a factor tree. So we take the number 48 and we're going to make what looks like sort of a little tree. We're going to put 2 branches out from 48. And we need to think of 2 factors that multiply together to make 48. So I know that 6 times 8 is 48. And then I ask myself, is 6 prime or is 8 prime? And neither of them are prime numbers. Both of them have factors that are more than just one in itself. So we break each of these numbers apart. Okay, give me 2 factors of 6. What times what is 6? Well, I could say 2 times 3 is 6. Then I look at those 2 branches on my factor tree and I ask, are those numbers prime? And yes, 2 is prime because only 1 and 2 go into 2. And 3 is prime because only 1 and 3 go into 3. Since these are prime numbers, I'm going to circle those. Okay, now let's go back up here to this part of our tree. What times what is 8? Well, I could say 2 times 4 is 8. And then I consider those 2 numbers. 2 is prime, so I'm done with that branch of my tree, but 4 is not. What times what is 4? 2 times 2. And of course we know that 2 is prime. So I can give the prime factorization, which remember our definition, it said it's the product, which means multiplication. It's the product of all prime numbers. So if I take all these prime numbers, 2 times 2 times 2 times 2 times 3, I get 48. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 3 is 48. If I multiply all these prime numbers together, I get 48. So that's called the prime factorization of 48. Now, you can also write that, just so you know, there's 1, 2, 3, 4 2's. So you can write that as 2 to the 4th power times 3. We'll be talking more about exponents later in the year, but if you're familiar enough with exponents, I want you to know that you can also write your answer this way. Now, there's another way to get the prime factorization of 48. If you don't like the factor tree method, let me show you this upside down division method. You take 48 and you put it in an upside down division box. Okay? Now, you must think of a prime number that goes into 48. It must be prime. So I'm going to use 2. 2 is prime. How many times does 2 go into 48? Well, it goes in 24 times. Then I take 24, and I must find something prime that goes into 24. Well, 2 works again. How many times does 2 go into 24? 12 times. Okay, now I must think of something prime that goes into 12. Well, let's use 2 again. 2 goes into 12 6 times. What's prime that goes into 6? 2. 2 goes into 6 3 times. Now notice, I just came up with a prime number in the upside down division box. Once I come up with something prime there, then I'm finished. My prime factorization are all the numbers along the side of the upside down division boxes and the very last one. So it's 2 times 2 times 2 times 2 times 3. Notice I got the exact same answer in both places. It's just 2 different ways to do it. You've got to decide which way you're most comfortable with. Okay, let's get the prime factorization of 24. Let's do the factor tree method first. Okay, let's make our tree. What times what is 24? I'm going to do 3 times 8. You might choose 6 times 4. Maybe 2 times 12. You can choose whatever you want. I'm going to choose 3 and 8. Now, 3 is prime, so I'm done with that part of my tree. But 8 is not, so let's keep going. 2 times 4 is 8. 2 is prime, but 4 is not, so let's keep going. 2 times 2 is 4. These are both prime. So notice that every part of my tree ends in a prime number. That means I'm finished. The prime factorization of 24 is 2 times 2 times 2 times 3. And if you want, you can write that as 1, 2, 3, 2 to the third, since there's 3 2's, times 3. Both of those answers mean the same thing. Now, if you think you might like the upside down division, let's do it that way. I have to find something prime that goes into 24. So let's use 3. 3 goes into 24 8 times. Now I must give something prime that goes into 8. Let's use 2. 2 goes into 8 4 times. Now I must find something prime that goes into 4. That's 2. 2 goes into 4 twice. Now, I've ended with a prime number. That means I'm done. So I take all the numbers down the side plus the bottom. 2 times 2 times 2 times 3. There's my prime factorization. Now, let me give you this hint. Here's how you know if you're right. Grab your calculator and multiply the 4 numbers we just came up with. Do 2 times 2 times 2 times 3. If it equals 24, then we know we have the right prime factorization. Okay, let's try another example. Let's find the prime factorization of 60. Okay. Now, anytime I have a number that ends in a 0, this is a nice one, because I know for sure, I might not be able to think of multiplication facts that equal 60, but anything that ends in a 0, 10 times something is that number. So 10 times what is 60? Well, 10 times 6. All right, now let's break apart our tree. 10. What times what is 10? How about 2 times 5? 2 is prime. 5 is prime. So I'm done with that part of my tree. Let's break 6 apart. What times what is 6? Well, 2 times 3 is 6. 2 is prime. 3 is prime. So I have my prime factorization. Let's write it in order. 2 times 2 times 3 times 5. There's my prime factorization. Okay, let's look at it doing upside down division. I must begin with something prime. If a number's even, I already know 2 goes into every even number, and 2 is prime, so I could start there. But I also know another prime number is 5, and anything that ends in 0 is divisible by 5. Okay, maybe I don't know 5 times what is 60. I could grab a calculator and check it. 60 divided by 5 is 12. All right, let's come up with something prime that goes into 12. How about 3? 3 goes into 12 4 times. Now I need something prime that goes into 4. 2 goes into 4 twice. Here I am at a prime. That means that I'm finished with my prime factorization. All the numbers are down the side and the bottom. So 2 times 2 times 3 times 5. Now, let's do one last example. 75. And some of you may say, oh, that's a big number. I'm not used to such a large number. Let's think about our divisibility rules that we learned in the last unit. If 75 ends in a 5, that means what can go into it? 5, right? Everything that ends in a 5 is divisible by 5. So if I don't know, let's grab our calculator. How many times does 5 go into 75? Well, if you check that out, you get 15. Okay? Now, what's prime that goes into 15? 3. 3 times what is 15? That's 3 times 5. Here's a prime number. That means we're done. 3 times 5 times 5. There's my prime factorization. Now, I skipped the factor tree method, so let's go back and do it that way as well. Okay, now in factor tree, remember, I don't have to start with something prime. So maybe some of you think 75, that's like 3/4. 3 times 25 is 75. 3 is prime, so I'm done with that part of my tree. 25 is not, though. 5 times 5 is 25. Now, 5 is prime, so I'm done. My prime factorization is 3 times 5 times 5.